So we're going to be going over test one solutions. I'm David, the Investor Data Boy, or you might as well call me the A plus ambassador. So question 4 says determine the area of a region bounded by x is equal to 1, x is equal to e to the power 1 plus y, x is equal to e 1 minus y, where y is equal to negative 1 and y is equal to negative 2. So now we're being given something like this. My drawing was rough, but I've put up the original question on the screen. So we are being told to say we have this graph and it's coming from 2 to 1, but then there are 2 here, and then we have to find the area. And then the problem with this question is we are being given the functions in terms of x, so these are functions of x and not functions of y. So that's why we must be very careful, because we'll be differentiating with respect to y and not x as we usually do. And then another thing is we have to determine, because these are 2, so we find the area below the curve and the area above the curve, above the axis. So now we're going to find 2 areas, and then there are many methods, of course, of doing this one, but I think mine is way easier and much straightforward and basically easy to understand. So now what I do in such scenarios is I flip the graph this way, so that now this one is, I have them in terms of x, so you can flip it this way or you can flip it this way, but I flip it in such a way that I have positive values this side and negative values this side, just as it ought to be. So now you have your x and then your y is here. So then when you're differentiating with respect to y, you'll be finding things in this order, and then you will not be confused because you've actually flipped the graph. So now we have the area that's this side and the area that's this side. Now with respect to the y-axis, you wouldn't say you have any area that's actually negative, because with respect to the x, because none of them are below are in the negative side of the x-axis. They are both below this region, and if this region was to be positive, both of these areas would be positive. So what I'm trying to say is if it's like this, we have a positive and a negative area, but then if it's like this, both areas are positive, and then the only thing that you have to do is add, because these are functions of x. So because we are used to differentiating something with functions of y, we'll make our x look like our y, so we will make our x be our y-intercept in this case. So with that brief explanation, I can then start. So I'm going to find this area and this area. So one thing that we have to find is the point where they meet. So if, let's say, they were meeting at maybe at y is equal to 1, we would I'm just giving an example. If, let's say, this point is obviously 0, and we'll try to check to confirm, but then if, let's say, this point was maybe 1, we would say the integral of 1 from 1 to 0, from 1 to 0 of this one, which is e to the power 1 plus 2y, would, if, let's say, this point was this point is 0, but then I'm assuming if, let's say, this point was something like 0.5, we would say 0.5, and then we would subtract, because when we find this one, we're going to find this one we're going to find the curve from here up to the y-axis. So this curve will be, let me use a red marker. So this curve would give us the area there, and then when we subtract with the area that's here, that would be given by this curve here. We would find the area that's here, then we would subtract it, and then we'd find the exact area that's just there. So now we would say 0.5, and then we would say 0.5 to negative 2 to negative 2. Firstly, after this one we would subtract it firstly from, let me just use another paper. Yeah, I think I can use this one. So we would say, if it was 0.5, we would say 0.5 e to the power 1 plus 2t minus e to the power 1 minus y dy, and then we would find the area here, and then we would do the same on the other side. So then now we start to find, first of all we find our point where these curves meet, which is this point, so that we have our values of integration, because we've only been given 2 and then we actually need 3. So then we are saying we just have to equate them to find our point. E to the power 1 plus 2y is equal to e to the power 1 minus y. So then what we do is we are going to solve for y, so that we find the value. So we are going to take the natural log of both sides, so that you can drop the power, that's 1 plus 2y. Then this natural log of e is basically 1, is basically 1, so we can neglect it. Then we're going to have that one being equal to 1 minus y. Making y subject, we're going to take this one this side and this one that side, so we're going to have 2y plus y is equal to 1 minus 1, so 3y is equal to 0. So now, since 3y is equal to 0, the only possible values of y are 0. So then we have the point where they meet. They meet at y is equal to 0, which was the case, but mostly it's not the case, so you just have to try to find this one. And then for the sake of showing you're working, you're going to do that. So now we go to finding our area. So now we have got let me go back to this one. So I've got this area from here to there, and then I've got the area from there to there. So let's write the equation for this one. So the area, I'll say area 1 is equal to we are going to get this area first, this whole area going all the way up to there, this one. This one will be given by 1 to 0, because 0 is where they are meeting. So 1 to 0 of e of 1 plus 2y, then minus this curve is also causing a certain area, so this curve is this one, so we're going to subtract it. So we're going to subtract this small area which is here. Then we're going to say e to the power 1 minus y dy. So this one will be our first area, so you can write it down. You can solve area 1 is equal to the integral of this one is simply e to the power 1 plus 2y over 2, because you're going to get this one, then the derivative of this one you're going to put in the denominator, which is 2, and then this one is what we are subtracting from 1. This one, the derivative is e to the power 1 minus y over negative 1. This negative and this negative, they are going to cancel out, so you have got to 1 and 0. This one is equal to let me just write it like this, 1 plus 2y over 2 plus e to the power 1 minus y over 1 to the limits 1 and 0. So now our e will have, when we plug in our 1 there, our e will be e to the power 3 over 2. Then when you plug in our 1 there, it will be e to the power 0, which is actually 1. Then this is being subtracted from, when you plug in our 0 there, you are going to have e to the power 1 over 2 plus our 0 there, that's e to the power 1 over 1. So then I think from this point you can actually subtract this. You're going to have your e to the power 3 over 2 plus 1. Then when you add these two, they are going to give you 3 over 2 e to the power 1. So then we try to find our next area. So our next area, so we found the first area, by the way. So then our next area will be given by, the area here will be given by, so area 2 is equal to, we have two graphs here. Allow me to put them in red. So we have this graph, this one here. So this one here, when we integrate it, we're going to find the area from this area is what we're going to find. And then let's write the equation for this area. We are going to have, it's bounded by this curve, so we're going to have the integral of 0 to -2 of the curve here is given by this equation, so that's e to the power 1 minus y. So now the second area is given by this curve, and then it's this area. So the first area we had the area of everything, now we have the area of this one. So we're going to subtract this small area with the area of the entire thing to get to this area, which is here. I hope you get the gist. So now we are going to say minus this area here is going to be given by this curve, e to the power 1 plus 2y dy. So now you see how flipping the graph has actually made this easier. If you have another easier method, you can actually use it. Others try to use a method where they change x into a function of y so that they can do it as we normally do. So then the integral of this one is simply negative e to the power 1 minus y. The integral of this one will be first minus e to the power 1 plus 2y over 2. Then we have the limits to be 0 and -2. So then we're going to find our area. Our area 2 is being given by, when we evaluate this one at 0, we have negative e to the power 1. Here we have got negative e to the power 1 over 2. This one minus negative e to the power, here this -2, when you put it here it will be positive, so it will be to the power 3 minus our, here is going to be, when you put our 2 there, that's -4. -4 plus 1, that's -3. So e to the power -3 over 2. So then our area is given by, finding this one, you're going to have, you have your 2 there, times over 1. So to this one, that's 2. That's -2e to the power 1 minus this one into this one is 1. 1 times this one is -2e to the power 1. That's minus negative e to the power -3 e to the power, this is e to the power positive 3 is -3 over 2. Then our second area is being given by -3e over 2 to the power 1 then minus this one will become positive, so that's positive e to the power 3 plus positive e to the power -3 over 2. So then we have the two areas. So area it will be equal to area 1 plus area 2. So then our area 1, we found it earlier, it was this one. So I'm going to say area is equal to area 1. Let me just plug in area 1. Area 1 is e to the power 3 over 2 plus 1 minus 3 over 2 e to the power 1. Then area 2 is what we actually have there, plus -3 over 2 e to the power 1 plus e to the power 3 plus e to the power -3 over 2. So then the area is going to be given by there are many ways of evaluating this one, but all these here are constants. So the way in which I like to do it is I get the you can get the common factors. I've got common factors in here, or you can add what's here and add what's there. So you can get to say the common factors, you're going to have e to the power 3 over 2 plus you have got e to the power 3, then plus the 1 is just alone, then you have got the negative 3 over 2 e to the power 1. You're going to have also here the negative 3 over e to the power 1, and then at the end we have got e to the power plus e to the power negative 3 over 2. So then our area is given by this one, so that's 3 over 2 e to the power 3 plus this one, that will be, first we have the plus 1, and this one plus this one will be, it's like this one, it's like it will double, so that will be 6 over 2 e to the power 1 plus e to the power negative 3 over 2. So then now, since the common denominator here is 2, let me get another paper. I can also use this one. So let's start from there, where we're saying the area is equal to the common denominator 2 into this one, that's 3 e to the power 3 minus, remember you can even evaluate from here, minus, in here we have got 1 into 2, that's 2 times this one, that's 2, this one will be negative, this one is plus, this one will be negative 6 e to the power 1 plus e to the power negative 3. So then you can evaluate this one now. You can get your calculator since you've actually simplified it. I hope you're able to see what I'm typing on the calculator. So that's 3 exponent 3 plus 2 minus e minus 6 e to the power 1 plus e to the power negative 3. So this one will give us 45.996. When you divide this one by the 2, it will give us, it's giving us 22.99835. So we've not been given to say if these are centimeters or meters or feet, so we're going to just say units squared. Then we can actually round this off to area is equal to 22.9984 units squared. And that's all. You've actually found this question. It looks lengthy, but it's something that's short. It's just because I was doing a couple of explanations as we were going on with the question. So that's all from me, and test 1 is also done as well. So stay tuned as we go to test 2.